Hi, it's Tim again on Digital Woodworking. I write for a popular woodworking magazine and I have a blog called woodworking.digital. Today I'm going to cover an important CNC basic, and that has to do with a home position. Let's get started. Most modern CNCs have what's called a home position. What that is the CNC first goes out to the extents or the limits of its movements on each of the axes, usually bumps into a limiter switch. In the case of this machine here, the x-axis is here. It hits a limiter switch that's behind the wall. My y-axis on the shorter axis, it bumps into a switch here. My z-axis, of course, is up and down. Once it hits all those limits, it ends up right over in this area right here. Let me show you. Okay, so now I'm in the home position on this CNC. That position is right flush to the edge of this table and right about here. Now every CNC has a different home position. It's just the way that the designers and the engineers create it. So for example, on a Laguna CNC, it's 4 inches off the table on the left side. Home position is essentially 0, 0, 0 for the CNC. The first two zeros are the x-axis and the y-axis. And that's where everything is based from. It's where all the numbers go up from here. In the case of this CNC, positive is this way for x, positive is this way for y. Other CNCs set home position differently. For example, the shape Oko goes to its maximum position. And once there, you can go down to 0, 0. Now limit switches vary in terms of their accuracy. Mechanical ones can be anywhere from 1 to 3 to 5 thousandths of an inch accurate. In the case of this machine, I'm able to get 2 to 4 thousandths of an inch accuracy over the entire table. Other CNCs use different limiter switches or electronic techniques for home position. So for example, optical limiter switches sometimes are accurate up to a 1,000th of an inch. In any case, the relevance of all this is if you can go to the same physical position on a table, then you have a connection between the relative movements of a CNC and the actual position in the physical world. Let me give you an example. I have a board here. If I was to set my origin point to here on the table and move everything right up to here, this would be my origin point. I could move this board anywhere I want on the table and move the origin point. But wouldn't it be nice to have one that you can come back to again and again? And that's where the home position is very valuable. In my case, like I said, I'm off the edge of the table, but I've also done something special here. I want to be able to check that my home position and the limiter switches are still in good shape. So down here, I've actually drilled a small 1/2 inch hole into the table. It's exactly 1 inch in from the home position. So I put a permanent position on this table, and that allows me to go to home position, move exactly 1 inch positive into the x-axis, and check and see if my limiter switches or something just isn't quite right. If it's exactly right, my home position will agree with this 1 inch here. To do that, I use this 1/2 inch pin. It's very accurate. So I chuck this into the spindle, I go over here, and I drop it down, and on my screen it says 1 inch. And if it doesn't drop down exactly into that hole at 1 inch, then I know that something's off down here a little bit. And I can adjust for that. But once I have that, I have a physical position on this table that I can repeat again and again and again. And that means anything I set on this table, I actually position at the same time every time on this table. Anything I set on this table, I can come back to. And that's really important, because what we're leading all this up to is souping up your CNCs for better performance, much faster setup, and repeatability. It's the big payoff. Over the next couple of videos, I'm going to show you how I set this CNC up for accuracy using what I just showed you on home position. And for today, this is Tim on Digital Woodworking. Talk to you soon.